Hello everyone. For this tutorial video, I'd like to discuss how the exponential functions work, which come in two distinctly different types, which is a variable raised to a constant power and constant number raised to a variable power. The first type is the most simplest, as in most cases where the exponent is an integer number, or a number that is not a decimal or fraction. You are simply multiplying the number by the number specified. So for example, x to the fourth power simply means x times x times x times x. However, with numbers that are not neat integers, the story becomes more complicated, but we would use root functions instead, which are essentially the inverse, i.e. they tell you the number you must multiply by themselves by the root time in order to get the number you want to find the root of. For example, 4 to the power of 1/2 means the square root of 4, which is 2, because 2 times 2 equals 4. Similarly, the third root of 8 is also 2, because when we multiply 4 by 2 again, you get 8. If the numerator in the fraction is not 1 but another integer, it is the same thing as multiplying the number by the power in the numerator, and then taking the root according to the denominator. For example, 2 to the power of 3/2 would be broken down into 2 cubed equals 8, and then the square root of 8. If you get a messy decimal number as your exponent, rather than a neat fraction, you should attempt to find the fraction that you can convert the decimal into, so that way you can use the shortcut. So if you saw it expressed as 2 to the power of 1.5, you would get the same exact result, as 1.5 is 3/2. Now that I've covered all of the subcases possible for case 1, I will move on to case 2, which is where the exponent is a variable and the base is a constant number. Since the exponent is a variable now, there is no set amount of times you multiply the base by, but rather the function would increase indefinitely. So for example, 2 to the power of x would be 2 multiplied by itself an indefinite amount of times, unless you plugged in a specific number for the x. Although this kind of exponential function is a lot less convenient than the first type, it actually has practical applications, and something like modeling the growth of a population. Because if we were to assume that human populations grow by a factor of 2 each time, we would use that exact function to model it. And although human population growth is much more complicated technically than simply 2 to the power each time, on a microscopic or cellular level, using 2 to the power of something is a model of cell growth, because of the fact that cells split in 2 each time, and so reproduce that way. Although generally we do not need exponential functions in game design, we can use it, for example, in life simulators. If you were to model the interest on a character's bank account, or if you wanted something to happen gradually at first and then increase speed dramatically later, as that is what an exponential function does if you look at its graph. So it can also be used to model warp speed acceleration for the motion of a car or similar object. Now that I've explained how exponential functions work, we can proceed to logarithmic functions, which, just like roots are the inverses of the first type of exponential function, logarithms are the inverses of the second type. And we can actually use logarithms to solve exponential function problems, i.e. to figure out the exact value of the variable in the exponential function. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.